Okay, so this part is called the composition of functions, and obviously what it involves is two different functions being combined. That's really what's happening here. And just to make sure we're aware of the notation, when you see this written, as you see on the board here, it is written looking like fog, and sometimes that circle is a little bit smaller than that, but another way is that it's called f of g, or the next one says g of f. And the next writing with the parentheses there, that actually means the same thing. It means f of g of x. I tend to like that writing a little bit better because I think it depicts exactly what we've been doing all along in terms of those operations with the values. That if you just grab a hold of that notation and what that's saying is, typically we see an equation or a function, excuse me, written in the form of f of x, but in place of x, we're putting inside whatever g of x is. In the same way, when we look at the next one, it says g of, and in place of x, you're putting the f of x. That means that this function is going in the spot of x. That's really what's happening. And in this next one below, we're saying f of f, which means you're putting the function inside itself. That means every time you see an x, you're going to see that equation. And that's really what's happening. So let's just do some examples and see how this actually plays out. So f of g of x, what that simply put, sometimes you'll see it said, you know, do this g part first, and then take the answer from that and plug it in for f, and that's fine, we'll get to that. But another way to just simply look at it is f of g. So that means we're going to look at the f of x function, but in place of x, in place of that x, you're going to take out this x. I'm just going to actually ungroup this so that you can see what I'm talking about. You're going to take out this x, take out the x, and you're going to put in place, well, I guess I can't ungroup that. You're going to put in place that x squared. And so the answer to f of g of x is x squared plus 5. Now, on the flip side, when it says g of f, what that basically is saying for us is instead we're going to start with the g function. So I'm starting with something squared, but in place of x, I'm going to put x plus 5. Now, f of g, this means the same thing as that first one, and then this one means g of f means the same thing as the second one. So this one here, f of g of x, is x squared plus 5 for the same reason as we showed above. And the next one there is x plus 5 squared. And of course, we could multiply that out, right? And get that final answer of that polynomial. All right, f of f. Again, what that means is wherever you see that x, think of parentheses, but instead of that x, we're going to write whatever it put inside there, and of course it was another one of those, which makes this x plus 10. All right, now let's look at it with a value, g of 3. And again, g of g, so we're going to start with g, which is something squared. In place of g, we're going to put x squared. And then it's saying in place of x, we're going to put 3. So I've got 3 squared. So that would be 9 squared, or 81. All right, let's try another one. This next one says f of x equals the absolute value of 2 plus x, and then g of x is negative x. So f of g, again, that means we're going to start with the function of f, 2 plus, but in place of that x, I'm going to put negative x, because that's g. And so this instead would have been written as 2 minus x, absolute value. All right? And that would be the same thing, right, as f of g. Same thing, same exact result. G of f, that means I'm going to start with g. So I'm going to start with negative, but in place of x, I'm going to put the absolute value of 2 plus x. And so this just would be negative. Absolute value of 2 plus x. Now what would that do when you put the negative on the outside of an absolute value? If the absolute value always makes it positive, then putting a negative in front of that would mean it's always negative. Let's try another one, f of f. Okay, that means that we're taking 2, absolute value, or 2 plus, But in place of x, we're going to replace that with the absolute value of 2 plus x. So it's kind of doubling up there. So it's 2 plus x, but there's the absolute value just everywhere. Now the truth is it would be quite redundant to have the one on the outside, mainly because once we do the absolute value of 2 plus x here on the inside, it's going to be positive, right? And so 2 plus any positive will be positive. It is somewhat redundant there. So you could just reasonably see that we wouldn't need the outside ones. It would simply be that. All right, g of 3 would mean we're going to start with g. We're going to put in g, and in place of x, we're going to put in 3. So negative 3 would just be 3. Last set of examples here. Hopefully, you can hammer this out. So f of g, which function am I going to start with? F function in place of x. I'm going to put that blank, though. And in place of that blank, or in place of that x, I'm going to put x plus 5 squared. So what I've really got is x plus 5 squared, and then I'm going to square it again. Or I can multiply that exponent, so it'd be x plus 5 to the 4th plus 5. Feel free to multiply that out if you just have tons of free time and you just don't know what to do with yourself. You can feel free to do that. G of f then would be take g, but in place of x, you're going to put f of x, or the x squared plus 5. And then you would have that. So this instead would be x squared plus 10 squared. A little different than what you saw above. All right, f of x and g of 3. That's where I would like to finish today, and I would like you to do that for class. I'm going to check for those two things. And in fact, it'll be part of your grades. So make sure that those last two examples are included in your notes.